So in previous classes, in previous class we discussed about the transient analysis of electrical circuits. We started with TC transient analysis, so that is also known as the time domain analysis. So first we started with RC series circuit, so without any excitation, right? So we derived some equations. So now we'll try to solve some problems. So based on that. So let us consider a circuit, something like this. So that is 3 ohm, and this is 2 farad, and this is 6 ohm, and this is 7 ohm, not 7 ohm, this is 4 ohm. So let us assume that voltage across capacitor, so this is VC, voltage across capacitor, VC at 0, so this value is 10 volts. So calculate VC at T for T greater than 0. Calculate the voltage across capacitor when T greater than 0. So calculate the voltage across capacitor for T greater than 0. So initial voltage across the capacitor is given, so which is equal to 10 volts. Right. So now thing is that, so how to solve these problems? How to solve these problems?
First, finding the R equivalent.
Yeah, finding the R equivalent, right? So here, so we have the general method is, right? So general method is, so applying. So if you doesn't know, if you are not aware, if you are not aware of this formula, right? If you are not aware of this formula, so where is that? So if you are not aware of this formula, right? So what we have to do is we need to apply KVL or KCL. So from that we need to obtain the differential equations. So from that you can solve this, right? So but you know the formula, right? So what is the formula? Voltage across capacitor. What is that formula?
V naught into
V naught e to the power minus
T by tau. So this is for the circuit. If this is the circuit is in this form, right? So this is C here and this is R here. So here this tau equal to, what is the value of tau? So tau is RC, right? Agree? So tau value is RC. So this is for this circuit, right? But the circuit is different from this circuit. So what we have to do is, so we need to deduce the circuit such that you will get this one, right? So that means, so here you have capacitor here, and so here resistor. So this capacitor is 2 farad, still its voltage is VC, right? So tell me what is the value of this resistance. So if you assume that resistance is R equivalent, what is the value of R equivalent?
30 upon
30 upon 13.
30 upon 13, right? Okay. So that is the voltage, right? So now from this, what is VC of T? What is VC of T?
10
Yeah, 10
e to the power minus
e
t
to the
upon
power of
13
minus
upon
T
13.
upon
13 upon
4.6.
4.6, right? Or you can write like this, right? What is this 1 by minus 4.6?
13 T by 30.
13 T by 30, right? Or minus 13 T by 30 volts. This is the answer, right? So that means this tau can be written as, right, the general equation for R equivalent
60, sir.
into C. Yes?
E power minus 13 by 16, sir.
Why 60?
RC na sir.
Sir, 2 is so multiplied.
Tau is equal to RC na sir. R into C. R is
Yeah,
13 by
yeah,
13.
yeah. So we missed that. So that means it will be 13 by 60. Is this correct?
Yes, sir. Now it's correct.
Yeah. So it is minus 13t by 60 volts. Understood? So this is how we need to solve the problems. First thing is we need to calculate the R equivalent, and tau value is R equivalent into C. So from that you have to substitute in the expression. Okay? You need to substitute in the expression, right? Someone may ask the questions something like this, right? For example, what is the voltage across capacitor? Voltage across capacitor for t equal to, maybe for example, at for example at 0.1 second, right? What is the value of capacitor voltage at t equal to 0.1 second? So how to solve this one? How to solve this one?
Sir,
What
we'll
is
So
your
at t equal
equal to
1, right?
0.1.
So it is equal to 10 into e to the power of minus 13 into 0.1 by 60. Okay? Solve this one, so that gives you the appropriate value, right? Understood? So that means, so this much of voltage you will get, right? So that is how we need to find the response of a simple RC circuit, So next we have another circuit, something like this. Say this is 2 farad, 3 ohm, and this is 2 ohm, and this is 6 ohm, right? And this is 20 volts. So we have switch here, set t equal to 0, the switch is open. So this is the circuit, right? The switch is open, right? So from minus infinite time to 0, the switch is closed, right? At t equal to 0 onwards, the switch is open, right? So what is the equivalent for t less than 0? What is the equivalent for t less than 0? So the circuit will be something like this, right? The switch is closed. So this is 2 farad, and this is 3 ohm, 2 ohm, and this one is 6 ohm, and this voltage is 20 volts. Understood? So this is for t less than 0. This is for t less than 0. If we assume that this is the capacitor voltage Vc of 0, right? So what is the Vc of 0? So how what is Vc of so how exactly it will behave, right? If the switch is closed for minus infinite time, right? So how exactly it will behave? How the switch will behave? Hmm?
open circuit.
So the switch will be open circuit, right? So that means the circuit will be something like this. right? So this is VC. Okay. So now tell me what is VC of 0 minus? So just before the switch is open. So what is this voltage? So how to find this voltage?
5 volts, sir.
How to find this voltage?
So that will be equal to the voltage across 2 ohm resistor.
Yeah. So this is equal to the voltage across 2 ohm resistor, since there is no current in this 3 ohm resistor. So since there is no current in this 3 ohm resistor, so the voltage is equal to 2 ohm resistor, right? So how to calculate that? So 2 ohm by 6 plus 2 voltage division, right? Into 20 volts. So how much this is? 5 volts. Understood?
Yes, sir.
So this is V of 0 minus. So this is also equal to V of 0, right? Agree? So this is the basic relation, right? So V of 0 minus equal to V of 0 equal to V of 0 plus. So what is the initial voltage across capacitor?
5 volts, sir.
5 volts, right? So here this data is given, or this circuit is given to find out the initial voltage across the capacitor. So this is given to find out the initial voltage across the capacitor, so which we calculated. So that is equal to 5 volts, right? So this is over. So now for t greater than or equal to 0, so how the circuits look like? So now the switch is open, right? So now the switch is open. So how it look like? So that means this entire thing is disconnected, right? Agree? This entire thing is disconnected. So now the circuit is look like this. So this is 2 ohm, 3 ohm, and this is 2 farad, and this is VC. So now anyone tell, so what is the voltage across VC of t for t greater than 0? What is the formula?
5 e power minus t by
5 into e to the power of
t by
Minus-
12.
minus T by
12.
what is
10.
tau here?
10.
10, sir.
Versus
5
into
into 2.
10, right? 10 seconds. So it is minus t power tau volts, so which is equal to 5 into e to the power of minus 0.1 t volts. Is this correct? Right. So this is how to calculate. So how to calculate the initial voltage from that initial voltage, right? So we need to calculate the other parameters or other voltages.
Sir, please repeat the question, sir.
Yes.
Again, what is it, sir? Again,
So here, so previous class, right? The initial conditions are given. Voltage across the capacitor is given, right? So this is given as 10 volts, right? So whereas here in the next question, so here the initial voltage across the capacitor is not given. Okay, but from circuit we need to calculate that. Okay, from the circuit we need to calculate. So we need to clearly observe the switch position, right? Switch is initially closed for a long period, and the switch is open at t equal to 0. So from that data, so we calculated the values, or we calculated the initial voltage. From the initial voltage, we have calculated the final waveform or final response for t greater than 0. Okay, so this is the one.
Sir, what is the R equivalent, sir, here?
What is R equivalent? So here,
Yes.
what is R equivalent? It is visible, right? So these two are in series. What is R equivalent?
That 6 ohm, sir?
Where is 6 ohm? No, that's why we, right. So here, so at t equal to 0, the switch is open, right? You can see here the switch arrow mark. Okay, the switch is open. So what does it mean? What it means?
Open circuit. That one.
So this is
correct.
open, right? So this entire thing is not comes into the picture. So only you left with this circuit. So this is the one. Understood?
Okay, sir.
Okay. So you can do this one as an example. This is 4 ohm and this is 12 ohm and this is 1 by 6 farad. 1 by 6 farad. So this is the voltage across capacitor. This is 24 volts and this is 6 ohm. So this switch is open at t equal to 0. The switch is open at t equal to 0. Right. If the switch is open at t equal to 0, find V of t for t greater than or equal to 0 and energy stored across the capacitor for equal to 0. Energy stored across the capacitor at 0.
PC of t is 8 e power minus 2 t kilowatts.
Yes, how much? 8
V of t is equal to 8 e power minus 2 t. Sir.
minus 2t. Yeah.
Yes, sir. Correct, sir.
What is the energy?
Convection.
What is formula of CV naught square, right? What is of CV naught square?
So 16 by 3, sir. 5.633.
16 by 3 means 5.333 joules, right? So these are the answers for this. Okay. One is 8 e to the power minus 2t volts and another one is 5.333 joules. Okay. So next we move on to other topic. So that is source free response of RL circuit, or also known as natural response of RL circuit. Right. So let us assume that you have a circuit something like this. And this is IR. Okay. So this is the circuit. So this is the circuit and this is energized, right? And the switch is initially closed, right? The switch is initially closed for a long time. The switch is initially closed for a long time and it is open at t equal to 0. And it is open at t equal to 0, right? Okay. So here, so when you are discussing that, so when it is energized, so when inductor is energized with 0 frequency, so how it will act as? how it will access? If this is the circuit, right? This is for t less than 0. Agree? Right? So now, so how this capacitor behave, how this inductor behave when it is excited from a 0 frequency voltage as current? So how it will behave?
Like it's
Will it be
short
open
circuited.
circuit or short circuit?
Short circuited.
So this
Short
entire thing
circuit,
acts
sir.
as
Short
a
circuit.
short circuit, right? So now, what is the current through inductor? What is the current through
Infinite.
inductor?
So infinite.
Infinite.
Why infinite?
Infinite.
Zero, sir. Zero.
Why 0?
Sir, potential is same, no, sir. Equal potential means zero. Short circuit means potential across
What
sides.
is the other side? You have voltage source or current source?
Current source.
Right. Now tell me what is the current? What is the current through the inductor?
Sir, I not.
I know.
Yeah, right. So this equal to I naught, right? So remember, if you have a voltage source, right, and this is short circuited. So in this case, if there is short, what is the current here?
Infinite.
Infinite, right? So the current is infinite. If you have a current source, and what is the current here? If it is equal to I naught, so what is the current here?
I know.
Same, right? Just simple logic, right? Okay, if you have, it is energized from voltage. If the voltage source is short circuited, the current is infinite. If a current source is short circuited, right, and it's the value of the current is equal to the current source value. So these simple things, right? So now the inductor current, right? So this inductor current is equal to I naught. What is the current through this resistor? What is the current through this resistor?
So zero.
Zero.
Right. So since it is, we have short circuit here, right, and other side you have source here, so that means this entire thing is bypassed, right? The short circuit is bypassing. That's why it is known as short circuit. The circuit is shortened because of the direct connection between any two terminals, right? So this entire thing is bypassed. So here the current flow, theoretically the current flow through this one is 0. Understood? Right? So this is happening, right? So this is happening for IL of 0 minus, right? What is IL of 0 minus in this particular case?
I not, sir. I not.
I naught, right? Now we have the property inductor will not allow sudden change in the current, right? So when you are studying the self-inductance concept, so inductor will not allow sudden change in the current. So now tell me what is IL of 0 and IL of 0 plus.
All I know.
I not only.
So
I
this
not
I
both
naught
are.
Both
and
are
this
I
is
naught,
also
sir.
I naught.
I naught.
Understood? Right? So inductor will not allow sudden change in the current. Similarly, the capacitor will not allow sudden change in the voltage. All right? Okay. So now, so this is the property we are obtained. So that means the initial voltage, sorry, the initial current through the inductor is I naught. In other words, the inductor is having some stored energy. So what is the stored energy in inductor? So how much energy it's stored here?
Half L I naught square.
Yeah, good. Of L I naught square joules. Right? So now how this circuit will be reduced for t greater than or equal to 0. So how this circuit will be reduced? So one side you have inductor, on the other side you have resistor, right? Agree for this?
Sir.
Okay. So assume that, so this is the direction of current. For example, you have R here and you have L here. So assume that, so that is the direction of current. Right. So what is this current? What is the inductor current here? What is the current that flowing through the inductor? Okay, we'll come back to that, right? So here, so what is the next step is, so we can apply KVL, right? So we can apply KVL. So how this will be marked? If this is plus minus here, so this is VR. One second. Unnecessary create confusion, right? So this is your IR, right? So this is your IL, right? So what is the initial value of IL? So this is equal to 0. This is equal to I naught, right? So here, so assume that this is the current that flowing, right? IL current, so that is flowing. Okay. So now this voltage, this is the voltage across inductor, and this will be the voltage across resistor. Agree?
Yes, sir.
Okay. Just I modified the circuit so that the current is in the clockwise direction. Right? So now tell me, I'm erasing this. So if you apply KVL, right? If you apply KVL, so what you will get? So VL, so there is no source here, right? So VL plus VR, so which is equal to 0, right? Understood. So what is voltage across inductor? If you know the current, what is voltage
LDI
across
by
inductor?
LDI by
LDIL by
LDIL
DT.
DIL
LDI by DT.
by dt, right? So what is the current here in this case? If you know the
IL.
resistance value,
IR,
I into
IL into R.
IL
IL
into
into R.
so which is equal to 0. Right. So this is the first order equation, right? So this is the first order equation. So we will try to solve this one. So DIL by, so one side you have other terms DL by IL, so which is equal to minus R by L into dt. Agree? Check once. I'm just rearranging the terms to obtain the solution in the solution for this differential equation. So this is how we will
Correct,
do
sir.
that, right? Right?
Yes, sir.
So what is the next step?
Integration.
So integration on both sides. So it will be DIL by IL, which is equal to minus of R by L into dt. Right. So our objective is to find out the current response in the inductor. Our objective is to find out the current response in the inductor for a given finite time t. The t is greater than 0. Right? The t is greater than 0. In previous case, we found out the voltage response across the capacitor. So now we'll find out the current response across the capacitor. Right? So now what are the limits for the time? So time it starts from 0, right? The
0
time
to T.
starts from 0. Understood? And it's what is the value is t. Agree? Right? So what is this here times what are the limits in this case?
I not
No.
to
0 is the voltage, sorry, 0 is the current. 0 is for 0 time, what is the current here? It is I naught,
I
right?
not.
What is here?
I is a function of
IL
T.
of t. So it is IL of t, right? I'm deleting this. Right. So what is the next step? So its resultant is ln, right? ln IL of
IL by
t
I not.
by I naught.
I not.
So which is equal to
minus RT
minus
by
R by L into T. Right. So from this, IL of T equal to I naught into e to the power of minus R by L into T. Agree?
Sir.
This entire thing is in here only. Correct?
yes, sir.
So this
Sir.
can be written as I naught into e to the power of minus T by tau form we usually write, right? So how to write this one? So it is L by R,
L
right?
by R.
So this is equal to L by R. Okay. Right. I'm erasing this. If you draw the curve for this one, right, with respect to time, so you have 0 here. So here, this is for IL of T we are drawing, right? So this is I naught, right? So how this curve will decrease? So it will decrease exponentially, right? Agree?
Sir.
So that means, so the curve will be something like this. At infinite time, practically at infinite, theoretically at infinite time, so it will reach to 0. So this is I naught into e to the power of minus T by L by R. Right. So next we defined time constant, right? I'm not discussing the definition again, right? So what is the value here if this is the time constant? What is the value?
By R.
I naught by R.
I naught by E, right?
Yes, I not be L by R time constant.
I naught by E, right? So that means I, so this tau value, so its value is equal to I naught by E. So equate these two. So what is the value of tau you will get?
L by R, sir.
L by R, right? So equate these two. Okay. So instead of T, if you substitute tau, so you can get tau equal to L by R. So which is equal to R, which is known as the time constant of RL circuit. Time constant of RL circuit. Understood? What is the time constant of RC circuit? So that is R into C. Time constant of RL circuit is L by R. It is L by R. So this can be, entire thing can be written as I naught into e to the power of minus T by tau. So basically, so this can be further written as L by R equivalent. Okay? So this L by R equivalent. So these things, so we need to remember. So inductor is having some current, stored energy. So that stored energy, so how the stored energy is dissipated? So how the stored energy is dissipated?
In form of heat,
Resistors.
In the form of
heat through
or
resistor.
it is absorbed by the resistor, right? It is absorbed by the resistor. So now similarly, so we'll find out. So what is the power or the energy absorbed by resistor? We'll try to calculate. So what is the voltage across resistor? I into R, right? In other words, IL into R. Okay. So what is the energy across this resistor? So it is IL square into R, right? Agree? Agree?
This is power, na?
Which one?
IL
Oh, yeah,
square into R.
IL square into R. So how much you got? So I naught into e to the power of minus T by tau square into R. right? So how to get the energy? So what we have to do is how to get the energy?
Integrate, sir.
Integration of 0 to t, so I naught into e to the power of minus lambda by t square here into r into d lambda, right? So lambda is some finite value. Otherwise, so omega r of t, if you have confusion, so we have some, so this p r of lambda into d lambda. Okay, understood? So this is how we have written in previous classes, right? So what is this one? So how much you got? How much you got?
Sir, I naught square tau by 2r.
I naught square
It means, sir.
it can be written as off into
Sir, half
L
I naught square
square
tau into 1 minus e power minus
1 minus
2t
e
by
to the
tau.
power of minus t by tau. Right. So its value, so at 0, what is its value? At infinite, what is its value? At t equal to 0, what is its value?
0, sir.
0, right? At here infinite time, what is its value?
Half
L I naught,
Of
square.
Li naught square. So which is equal to initial stored energy across the capacitor. So omega c of 0. Understood? So this is about a simple RC circuit, so RL circuit. Right. Things we need to remember is that the time constant of RL circuit is L by R, and its response is I naught into e to the power of minus t by tau. So we'll try solving this simple problem.
So 1 second, could you go back, sir? 1 second.
Yes.
Thank you, thank you.
Say it is 20 volts, 2 ohm, 3 ohm, 6 ohm, and this is 3 ohm, and this is 2 Henry. So this is I. So calculate I of t for t greater than or equal to 0. And the switch is open at t equal to 0. So first thing is the initial current through the
Initial
circuit
current
is not given, right? So initial current through the circuit is not given. Okay. So what we have to do is, first we need to draw the equivalent circuit for t less than or equal to t less than or equal to 0. So what is the equivalent circuit? So it will be something like this, right? The switch is closed. So this is 2 ohm, 3 ohm, 6 ohm, 3 ohm, and this is 2 Henry, right? And this is 20 volts. The simple thing is that, right, under steady state, the inductor is short circuited and the capacitor is open circuited, right? So that is simple thing, right? So this is short circuited, right? Agree? Inductor is short circuited and the capacitor is open circuited. So now tell me, what is the current that flows through this inductor? What is the current? So what is the current flows through this 3 ohm resistor?
0.
Which goes through the 3
Zero,
ohm
right?
resistor, sir.
So there is no meaning of this 3 ohm resistor. So we can remove this. So now tell me what is the current that flows through this this circuit. So that is equal to the 6 ohm resistor, right? So what is the current that flows through the 6 ohm resistor?
5/3.
How much? 5/3. So how you are calculated? So this 3 and 6 will comes in parallel. So first thing is we need to calculate this total current I. So what is I here?
So 5.
20 by 3 plus 6, 3 in parallel, right? What is the resultant?
So 2.
2.
2 ohm, right?
So 2
That
plus
means it
2
is
is
4
0.
amperes. So now this current IL, so what is IL? How to calculate IL? Current division, right? So current division, see here, so there is some IR, it is flowing, right? So
Sir,
how to
sir,
calculate
it will
that?
be 5
So
amperes, sir.
current is 5 ampere.
This one, which one is 5 amperes?
Sir, I.
Sir,
I
total
measure.
current.
20 by 3 plus 2 is 5, 4 only, no?
20
plus
by 2 plus 2.
it will be.
2 plus 2, sir.
Okay, this is 2, sorry. This is 5 amperes, right? So how this IL is divided? So how much current that's flowing here and how much current that's flowing here? So how to decide that? Based on the resistances, right? So what is the current that's flowing here? Current division, right? So the opposite one is 3 by 3 plus 6 into 5, right? Agree? Agree?
Yes, sir. Correct.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So what is the current that's flowing?
5/3 amperes, sir.
5 by
3.
5 by 3 amperes. So that is the initial current, that is I naught. So it's equal to 5 by 3 amperes. Understood?
Yes, sir.
Any doubts here? We are going a bit fast.
Why you remove that 3 ohm resistor, that one?
Good question, right? So here this is the one, right? So here there is short circuit here, right? So current will always flow through the lowest resistance path, right? If it is short circuit means so zero resistance. So obviously it will flow through this path only. So there is no current here. Understood? Okay.
Okay, sir. In
Current
case of
will always flow through
in
the
case of
low
inductor,
resistance. Yes.
in case of inductor, it is short circuited, and in case of capacitor, it is open.
Yeah, that is simple thing, right? Under steady state, inductor will be short circuited and the capacitor will be open circuited. This is only true when it is excited from a supply of zero frequency, whether it is a current source or voltage source. So not for everything. Okay. So what is the next step? What is the next step? So we need to draw for t greater than or equal to 0. So this entire thing is open, right? So now the circuit will be something like this. So now we have inductor will present. So this is 6 ohm, this is 3 ohm, and this is 3 ohm again, and this is 2 Henry. So now tell me, so what is the response? I of t or t greater than 0. Let's straight away tell the response, right? So first thing, what is time constant here? L by R equivalent, right? So what is R equivalent here? What is R equivalent?
9 by 4.
9 by 4.
9 by 4. Okay, so that means L is 2, so it is 9 by 4. So how much this is? 8 by 9? 8 by 9 seconds.
Yes, sir.
Okay, so what is I of t?
greater than 0, the 20 volts and 2 ohm resistor is not considered.
What you are saying?
Why t greater than 0, the 20 volts and 2 ohm resistor is not considered.
We have discussed it again, no, in the previous class, in the previous problem also. This switch is open. Okay, right. So that means there is no connection between this circuit and this circuit. Now this circuit is divided into two parts. Okay, the switch is open, right? Okay, so now this 20 volts is no longer supplying the power. Understood?
Okay. Yes, sir. Got it.
This we discussed, I think 3-4 times. Today's class only we discussed. So what is I of t now? It is initial value I naught, right? So 5 by 3 into e to the power of minus t by tau. What is tau here? 8 by 9. So that means it is 5 by 3 into e to the power of minus 9t by 8 amperes. Understood?
Yes, sir.
You have any doubts?
No, sir. So
Okay.
that R equivalent, sir, so it will be 6 by 5, right?
You guys only said that it is 9 by 4. So these two are in series, right? 9. 9 into 3. So 9 into 3 by 9 plus 3. How much it is? 27 by 12. Okay. 27 by 12 is 9 by 4 only. Yeah, it's true only. Okay, we'll move to the next problem. So this is 24 ohm. So this is 6 ampere. Okay. So this is open at t equal to 0. This is the current I, right? So find I of t for t greater than or equal to 0. Okay. So first thing is Right, we need to find out its equivalent circuit for t less than 0, right? So how that equivalent circuit will look like? So how it will look like? So we have a current source here. So this is 24 ohm. So this is 6 ampere. So next we have, so this arrangement.
Sir, 5 ohm resistor is removed now. Sir.
Wait. So this is, so how this will act? So how the inductor will act?
Short circuiting.
So this inductor will act as a short circuit, right? So this acts as a short circuit. So now tell me, so how the circuit will modify? Just you need to observe carefully, right? So here, if you observe that this 5 ohm resistor is also short circuited, right? Agree?
Yes, sir.
Right. So that means the current that flows through this 5 ohm resistor is 0. So that means ultimately this 12 ohm and 8 ohm will comes in parallel, right?
Yes, sir.
So one point is touching here and another point is touching here, right? So that means it's a parallel connection. So here there is no current that's flowing here because of the short circuit. So now this is 24 ohm. So now the thing is that, so all these three are in parallel. Agree for that?
Yes,
Sir.
sir.
Okay. So now the thing is that you need to find out this current. So that means the
And this
current
12 ohm
that goes through 12 ohm resistor. Okay. So how to find out that? How to find out?
24, 12 and 8 parallel now, sir.
Yeah. So this is the circuit will be modified like this, right? So you have the simple thing.
So 2 ohms.
So this is, wait. This is 12 ohm, right? And this is 8 ohm. And this is 24 ohm, right? And this 6 ampere current. So we need to calculate this current, IL. So how do you find? This is the one, right? Agree? So now how to find this current? So we need to apply current division, right? So how to apply current division in this simple case?
12 by sum.
How to apply simple?
Nodal.
Add that 24 and 8 volts, sir, first.
Yeah, you need to find the resultant of this 24 and 8, right? What is the resultant of 24 and 8? What is the resultant of 24 and 8?
6, sir.
6, right? That means the entire thing you can scrap it and it will be 6 ohm, right? Agree? So now it will be 6 by 12 plus 6 into 6. So this is the current that is flowing, right? How much this value?
2.
2 ohms. 2 ohms.
2 ohms.
2 amperes, sir.
2 ampere.
Yeah, 2 amperes. Understood? Just simple
Yes,
thing.
sir.
So it's just 2 amperes. Okay. Right? So next thing is for t greater than 0. So this entire thing is again, so this entire thing is discarded. So you left with the circuit something like this. So you have 2 Henry here, 12 ohm, 8 ohm, and this is 5 ohm. So what is R equivalent here? What is R equivalent?
So 4 ohm.
4, sir.
So this 12 and 8 are in series, right? And in parallel with this 5 ohm resistor. Okay. So that means 100 by 25, 4 ohm. So R equivalent is 4 ohm, right? R equivalent is 4 ohm. So what is tau now? What is tau value? 1 by 2, that is 0.5, right? Is this 0.5?
Yes, sir.
Okay. So what is the final answer? What is I of t per t greater than or equal to 0, what is that value?
2
It is
into e to the
2
power
into
of
e to the
minus
power of
2t.
Power of
minus
2t.
2t amperes. Okay. So this is how to solve or how to find out the initial current or initial conditions simply, and how to find out the time constant, right? So you have to pay attention. So when you're short circuiting the inductor or when you're open circuiting the capacitor, so how the circuit is modifying. So by simple logics, you need to find out the initial conditions. Okay. Understood. So next I will give you one example problem. See, next class we'll discuss this. You try to solve on your own. So initial conditions are given, right? So I of 0 is given as 7 amperes. Okay. So find I of t and Vx. This is for t greater than or equal to 0. So this is also same. So find I of t and V of x for t greater than 0.
Numerical solution.
Yeah, do this one. So first thing is, what is the basic thing is that, so we need to formulate the differential equations, right? So assume that this current is I1 and this current is I2. So from that you can solve this problem and formulate the differential equation for I in terms of I. So we need to formulate the differential equation in terms of I. So that is inductor current, right? So how you are formulating, so that is important. Okay, anyway, next class we'll discuss this thing. So, have any questions?
No, sir.